Alright guys, your essential question for today is how do we solve right triangles, sides, and angles? Well, for the most part, we've been solving right triangles only finding their sides. For today, we're going to be finding the angles. Your vocabulary includes the words inverse and arcsine, arccosine, and arctangent. You will have a quiz over this material at a later date. Okay, let's take a look at an example. To solve a triangle means that you want to find all the measures of its sides and angles. Since a triangle has three sides and three angles, that means that you should end up with three measures for your sides and three measures for your angles. Now, obviously, you're going to be given some information in order to solve it. For example, let's say you have right triangle ABC, and I specify that angle C is the right angle. So I know that angle C is 90 degrees. I also tell you that angle B is 78 degrees. So this angle is 78 degrees. One thing I can do is I could go ahead and subtract 90 and 78, and that would give me angle A. But actually, I'm going to do it a little bit differently in a second. I want to find sides A, B, and C. I also am given that side A is 41. So I'm going to go ahead and say that side A is 41. Well, angle B is what I'm given, so I'm going to label my sides appropriately. That means side B would be my opposite side, and side A would be my adjacent side, and C would be my hypotenuse. So since this is my angle and I'm given the adjacent, let's say I want to find the opposite. Well, what I would do is I would use the trig ratio, because tangent is opposite over adjacent, so I'd have tangent of 78 degrees is equal to B over 41. Alright, remember, this is what we covered for the past 2 days. Put this over 1, cross multiply, so I'm going to have 41 tangent of 78 degrees is equal to B. And so using my calculator, that would give me 192.890, and that would be the length of side B. Alright, if I wanted to find side C, I could use the cosine formula because I'd have adjacent and hypotenuse, so I could say cosine of 78 degrees is equal to adjacent, which is 41, over hypotenuse, which is C. Again, put this over 1, cross multiply, so I get C cosine of 78 degrees equals 41. And then, making a mess there. And then to solve this for C, I'm going to divide by cosine of 78 degrees. And then if I punch this into the calculator, it would give me approximately 197.199. Alright, so I've got all three sides now. Side A, side B, side C. I've even got angle B and angle C. Now again, one way that I could find angle A is I could subtract 78 from 90, and that would tell me that angle A is 12 degrees. Another way of doing this is to use something called an inverse trig function. So, for example, let's say that I wanted to find out what angle A was. And I know that side A is 41, and we found out that side B was 192.890, and we found out that side C was 197.199. So I could use any trig ratio I want. I'm just going to use the sine trig ratio. So let's just set this up. I'd have sine of angle A is equal to opposite, which would be 41, over hypotenuse, which would be 197.199. Alright, I want to solve this for angle A. So, in other words, I need to get rid of my sine function. In other words, I want to do the inverse of sine. Well, that's where the idea of arcsine comes into play. So, in other words, if I want to get rid of sine, I would do sine's inverse. So, what this looks like in red is sine to the -1 power, but that basically represents the arc sine or the sine inverse, and that button is on your calculator. But what happens is the sine inverse and the sine cancel each other out, so that leaves me A, and then if I do sine inverse of 41 over 197.199, my calculator will give me 12, and that was the answer that we found from just subtracting it from 90. Now you're probably thinking, well, if I can just subtract it from 90, there's no point in doing all that other work. But still, it's very important that you do understand that if you ever want to find an angle, that's the key point here. Whenever you want to find an angle, you have to use the sine inverse or the cosine inverse or whatever trig ratio you're using. You have to use its inverse or its arc function. For example, let's say I give you another triangle, and this time the only two pieces of information I tell you is that side B is 21 and that side A is 11, and that angle C is your right angle. Well, the issue here is that I don't know what either one of my angles are. So I'm going to have to do an inverse trig function in order to get one of the angles first. Doesn't matter which one I find, so I'm just going to try and find angle A first. Well, from angle A, side A would be opposite, and then side B would be adjacent. So I would do tangent of angle A is equal to 11 over 21. Again, to solve for A, I'm going to do the inverse of tan. So I'm going to have tan inverse of 11 over 21. And so I'm going to have tan inverse of 11 over 21. That will be 27.646. But since this is a degree, I'm just going to round it up to 28 degrees. So we're going to say angle A is 28 degrees. All right, now it'd be very easy to find angle B. All I'd have to do is subtract the 28 from 90, but since we're studying inverse functions, I'm going to do just that. I'm going to say that this time for angle B, tangent of angle B is going to be 21, because now that's opposite, over 11, because that's now adjacent. And so then angle B would be tan's inverse of 21 over 11. And so I'm going to have tan inverse of 21 over 11. And that would give me 62.354. And so I'm just going to leave that at 62 degrees. And what's ironic is you can check yourself. If you add 62 plus 28, you get 90, and the other angle's 90. Now, to find side C, you got some options here. You could, if you wanted to, use Pythagorean theorem, but I'm going to use a trig ratio, and I'm going to use cosine. I'm going to say cosine of 28 degrees, so this angle, equals 21 over C. And so I'm going to put this over 1, and I'm going to cross multiply, so I'm going to get C cosine of 28 degrees equals 21, and to solve for C, I'm going to divide by cosine of 28 degrees, so I'm going to have 21 divided by cosine of 28 degrees, and that'll give me 23.784. And what's interesting, guys, is that if you didn't want to use cosine, you could use sine, or secant, or even cosecant. That would help also, or Pythagorean theorem, and you would all get the same answer for that as well. Okay, it wouldn't be a trig day if I didn't have a word problem for you. So here's our word problem for today. It says, in 1906, Teddy Roosevelt designated Devil's Tower National Monument in northeast Wyoming as the first national monument in the United States. The tower rises 1,280 feet above the valley of the Belforce River. So whenever you do a trig problem, make sure you take the time to draw that picture. So here's my tower. Oh yeah, looks really great. You can tell that I was an art major in college. And basically this tower is 1,280 feet, 1,280 feet tall. All right, let's look at part A. It says if the shadow of the tower is 2,100 feet long at a certain time. So if you can imagine, this tower is casting a shadow that is 2,100 feet long. And let's pretend that the sun, obviously, is up here. And so it's casting that shadow down. I know that's horrible to see, so let me try green instead. Alright, it says find the angle of elevation of the sun. Well, the angle elevation is going to be this angle right there, angle of elevation to the sun. And so this is my right angle. And so if you notice, from this angle of elevation, this is opposite, this is adjacent. So to find this angle for part A, I'm just simply going to do tangent of my angle is going to be 1280 over 2100. Since I'm trying to find an angle, I'm going to do tan inverse of 1280 over 2100, and that would give me an angle of 31.363 degrees. We're just going to simply say that's about 31 degrees. Okay? Okay? Alright, let's look at B. How long is the shadow? So let's say we don't know how long the shadow is when the angle of elevation of the sun is 38 degrees. So this time we're going to change it up a little bit. The tower hasn't changed sides, but this now is 38 degrees, and it wants to know how long the shadow is. Well, I'm still going to have to use tangent, but this time it's going to be set up differently. Tangent of 38 degrees equals 1280 over x. Notice we're not trying to find an angle, so we're not going to use the inverse function. We're just going to cross multiply and then divide by tangent of 38 degrees. And so 1280 divided by tangent of 38 degrees would give me 1,638.325 feet. And so that would be the length of the shadow. 1,638 feet. Alright, for the last one it says if a person at the top of Devil's Tower sees a hiker at an angle of depression of 65 degrees, how far is the hiker from the base of the Devil's Tower? So, alright, Mr. Kelly's up here. Yeehaw! Yay! Yay! And I see a hiker down here. Hello, how are you? Do-do-do, do-do-do. How are you, Mr. Kelly up here? Alright, hiker down here. He wants to know how far the hiker is from the base of Devil's Tower. Now, of course, this is x, what I want to find, but it doesn't say the angle of elevation. It says the angle of depression to that person is 65 degrees. Well, one thing you should remember is that the angle of depression is equal to the angle of elevation. So this is also 65 degrees. So what I'm going to do is have to use tangent. I'm going to do tangent of 65 degrees equals 1280 over x. Remember, I'm not trying to find the angle, so I'm not going to do inverse, but I am going to put it over 1, and I am going to cross multiply. And so to solve this for x, I'm going to divide by tangent of 65, and so that would end up giving me, it end up giving me 596.874 feet. So approximately 597 feet. So that hiker better hurry and get to me real quick. Alright guys, that's it for today.